Imagine this. You ask your AI assistant to summarize a web page. It reads the content and suddenly starts leaking data, executing unexpected actions, or ignoring its own rules. You didn't tell it to do anything malicious. So what happened? The attack wasn't in your prompt. It was hidden inside the data itself. This is indirect prompt injection. And unlike direct attacks, this one scales silently across the web, documents, and emails. Today, we'll break down how it works, why it's more dangerous, and why it's becoming the biggest security risk for AI agents. The key difference here is the attack surface. In direct injection, the user provides the malicious input, but in indirect injection, the AI retrieves external data, web pages, documents, emails, and treats it as trusted context. Inside that data, an attacker hides instructions. These could be invisible to humans, like white text on a white background, or disguised as normal content. When the AI reads it, it doesn't see data. It sees instructions. And just like before, it tries to follow them. Why does this work so well? Because the model has no native concept of trust boundaries. It doesn't know which parts of the input came from a secure system prompt, and which came from an untrusted web page. Everything is just tokens. So, when malicious instructions are embedded in retrieved content, they compete on equal footing with system rules. And often, the more specific or recent instruction wins. The AI isn't being hacked in the traditional sense. It's being manipulated through its own reasoning process. This becomes far more dangerous with AI agents. These systems don't just generate text, they take actions. They can call APIs, send emails, query databases, even execute code. So if a malicious instruction says, send this data to this endpoint, the AI might actually do it. One hidden sentence in a web page can cascade into real-world actions. This turns prompt injection from a content issue into a full-blown system exploit. At the code level, this looks completely harmless. You're just fetching a web page and passing it to the model. But if that page contains hidden instructions, you've unknowingly injected malicious prompts into your system. The model doesn't distinguish between content to summarize and instructions to follow. It's all part of the same context. Defending against this requires a mindset shift. You have to treat all external data as untrusted, sanitize inputs, segment content so instructions can't blend with data, restrict what actions the AI can take without approval, and most importantly, verify outputs before executing them in the real world. Because once your AI starts acting, not just talking, the stakes become much higher. Indirect prompt injection is what makes AI security truly challenging. The attack isn't visible. It rides along with the data your system already trusts. As AI becomes more connected and autonomous, these hidden attacks will only grow. If this opened your eyes, subscribe. Next, we'll break down how attackers perform jailbreaking.